Alright guys, today's goal, the learner will understand how to construct and interpret binomial distributions. A random variable is a variable whose value is determined by the outcomes of a random event. For example, when you roll a six-sided die, you can define a random variable x that represents the number of showing on the die. So the possible values of x are 1, 2, 3, 4, 5, and 6. For every variable in the probability distribution can be defined. Alright, probability distributions. A probability distribution is a function that gives the probability of each possible value of a random variable. The sum of all the probabilities in a probability distribution must be equal to 1. So if you add them all up, it equals 1, which is 100%. Okay? So what they're talking about here, if we're rolling a six-sided die, what's the probability I roll a 1? Well, it's a 1 out of 6. A 2, 1 out of 6. Now, if I said what's the probability of rolling at most a 3, which ones would those equal? Well, what's the probability of rolling a 1? 1/6. Plus the probability of rolling a 2? 1/6. Plus the probability of rolling the 3 is 1/6. So you add those together, it's 3/6, so 1/2. So you have 1/2 if you roll at most a 3. Another way of thinking about that is rolling a 1, 2, or 3. See how we're just finding the individual probabilities and adding them together. Okay? So let's look at an example here. Let x be a random variable that represents the sum when two six-sided dice are rolled together. So two six-sided dice. Well, how many outcomes are there for the first? 6. For the second, 6. So total, 36 outcomes. Okay? That's just good to think about. Make a table and a histogram showing the probability distribution for x. So here's the histogram. See how they have the probability on the side and the sum of the two dice on the bottom? Well, if you roll two dice, you can roll a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Okay? Then see how they made this table to be able to create the histogram? How many possible ways are there to get a sum of 2? Well, 1 in 36. A sum of 3, there's 2, 1/18, 1/12, 1/9. Okay. So, what if I said, what's the probability of rolling a total of 6 or 7? Well, the probability of rolling a 6 was 5/36. The probability of rolling a 7 was 1/6. Add those together, you have to go 6 over 6. So that one is just, so we can change that to 5 over 36 plus 6 over 36. So you'd have a probability of 11 over 36. Okay? But we need to see how we're creating these histograms here. Okay. So a tetrahedral die has 4 sides, number 1 through 4. Let x be a random variable that represents the sum when 2 such dice are rolled. Okay. Make a table and histogram showing the probability. So let's start there. Okay. So to get the total outcomes, you do 4 times 4, so there's 16 total outcomes. Let's see our sums of 2 four-sided dice. So the x sum, you could sum to 2, 3, 4, 5, 6, 7, 8. The total ways and the probability. Okay. The only way you can roll 2 is a 1 and a 1. So you have one way. 3, you could go 1, 2, or 2, 1. So you have 2 total ways. 4, you could go 1, 3, 3, 1, or 2, 2. So 3. 5, you could go 1, 4, 4, 1, 2, 3, 3, 2. So 4. 6, you could go 4, 2, 2, 4, 3, 3. So you have 3. 7, you could go 4, 3, or 3, 4. 8, 4, 4. So this would be 1/16, 1/8, 3/16, 1/4, 3/16, 1/8, 1/16. Okay. So now we have to make the histogram. Oh, I forgot to label. So this is the probability sum of 2 dice so let's see, our sum could be 2, 3, 4, 5, 6, 7, 8. Our probability, just go by, there's 1/16, 2/16, 3/16, 4. So label this 1/8, 1/4. Okay, so 2 was 1/16. So their scale is the 1/16. 3 was 1/8. The 4 was 3/16. The no, 1/16, 1/8. I'm off one here. Hold on a sec. The probability of summing a 2 is 1/16. So there's that. The probability of rolling a total of 3 is 1/8. Of rolling a 4, 3/16. Of rolling a total of 5 is the 1/4. And then it goes back down. So there's our histogram. It says, what is the most likely sum when rolling 2 dice? Well, the most likely sum, so part A, what is the most likely sum? 5. Because it had the highest probability. Then part B here, what is the probability that the sum of dice is at most 3? Well, you would have 1/16 plus 1/8, but that's 2/16 plus 3/16. So that would be 6/16. So the probability would equal 3/8. Okay? All right. So, binomial distribution. One type of probability distribution is a binomial distribution. A binomial distribution shows the probabilities of the outcomes of a binomial experiment. So what's a binomial experiment? A binomial experiment meets the following conditions. There are n independent trials. What that means is doesn't matter what happens on the first trial, doesn't affect the second. Each trial has only two possible outcomes, success and failure. Okay? The probability of success is the same for each trial. This probability is denoted by P. The probability of failure is given by 1 minus P. For a binomial experiment, the probability of exactly k successes and n trials is probability of k successes equals n choose k, p to the k, 1 minus p, n to the n minus k. Okay? So we are going to have to know this equation, and we are going to have to be able to use it. Okay, so it says draw a histogram showing the binomial distribution for your survey. Okay? So let's make a little histogram up here. And we're going to have options of 0, 1, 2, 3, 4, 5, 6. This is the number of households with soccer balls. And this is the probability. Okay, so before I make the scale for probability, I'm going to calculate them. So what do I do to calculate them? Okay, so we use this equation here. So the probability of 0 is going to be 6, choose 0, times 0.61 to the 0 times 1 minus 0.61 to the 6th minus the 0. Okay? So we have to set up now to be able to calculate the probability for 1. So we do 6, choose 1, 0.61 to the first, 1 minus 0.61 to the 5th, because 6 minus 1 is 5. And then the probability for 2, 6, choose 2, 0.61 to the second, 0.39, because that's what 1 minus points it to the 4th. Probability for 3. 6, choose 3, 0.61 to the third, 0.39 to the third. Halfway there. Probability of 4. 6, choose 4. 0.61 to the fourth. 0.39 to the second. Probability of 5 of them. 6, choose 5. 0.61 to the fifth. 0.39 to the first. Probability of 6. 6, choose 6. 0.61 to the sixth. 0.39 to the 0. Okay? So we have to calculate all these now. So let's make sure we calculate the first one here. You should get 0.0035. For the second one, you should get 0.3 0.302. For the third one, we would get 0.06595. For the fourth one, we would get 0.50211. For the fifth one, 0.32675. For the fifth one, sixth one, sorry, 0.19764. For the last one, 0.05152. Okay, so we have all these percentages. Now what I'd like you guys to do without me doing it is take these percentages, put them into the histogram. So make a good scale and level it out. Okay? Alright. So, symmetric and skewed. Symmetric, same thing as a graph. The line of symmetry means if you fold the data over that, it's almost identical. Skewed means it's not symmetric. And see how it's all big at the end? That means it's skewed. Another way it could be skewed is this way. Or it would be like the opposite. Okay? So after you graph what we just did, after you do the histogram of that, tell me if you think it's symmetric or skewed. It might not be quite either, but tell me which one you think it's closest to. See you guys tomorrow.